Good morning to the Facebook community. We are live here at NASA's Armstrong Flight Research Center for the Dream Chaser Captive Carry Test. All the action is going to be happening right here behind us. We're going to bring it all to you live. We're going to take your questions, so be sure to start leaving those in the comment section. My name is Kimberly Schwan. I wanted to welcome everyone. I'm Communications Manager for Sierra Nevada Corporation's Space System, and I am joined by my colleague, Mr. Steve Lindsay, who is Vice President of Space Exploration Systems for SNC. He also happens to be a former NASA astronaut, which is amazing. He's going to give us all the scoop on the Dream Chaser program. He heads up the program, and he is going to take all your questions and give us all the scoop on today. Steve, thanks for joining us this morning.
It's good to be here. Beautiful morning here at Edwards Air Force Base. Looking forward to this flight test.
Yeah, it is. For all of you guys out there, it is beautiful. We just had the sunrise. And just to set the scene for you, it's supposed to be 108 degrees today. So it's going to be toasty. We are in the middle of the desert. We have a spacecraft, the Dream Chaser, which is going to be lifted by a helicopter. I think it's safe to say that we can geek out over the images that we're going to see today. Is that right?
It should be cool. So we're going to, the vehicle behind us, we're going to lift it up with that helicopter, fly for about an hour, hour and a half, and do some really critical flight test procedures and some workup tests, which will culminate later on this year with a free flight test. So we're really excited about it. It's a high pressure test, but should be a fun test to watch.
Yeah, it's going to be really visual. So, Steve, the spacecraft, the Dream Chaser, has been out here in California at this historic center, Armstrong Flight Research Center, for most of this year. It's been doing ground tests. Tell us what the tests have been going on this year.
So we brought the vehicle out earlier this year, and what we do is we do a series of build-up ground testing, culminating in flight test. And so since we've been here, we've one of the first things we did was we had to ship the vehicle here from Colorado. We had to take the wings off to ship it. We got it here, got the wings reinstalled, got all the systems checked out, and then we went through a series of what are called integrated tests. And integrated tests are where you turn on all of the systems, you see how those systems work together, and you test it in as close to a real flight environment as possible. And some examples of those tests we did is we did a series of tow tests. And what a tow test is, we essentially hook up a truck to the vehicle, we drag it down.
That's a crazy image in itself.
Yeah.
I know we just posted some video of that on our Facebook page if you want to check that out.
But the interesting thing about those tow tests is that is probably the best integrated test we can actually get on the vehicle prior to actually flying it. Reason being is we'll tow it up to a certain speed, and we've gone up to as high as 60 miles an hour down the main runway, and then we actually release the vehicle from the truck. And what happens is when we release the vehicle, it sends an automatic signal to the vehicle to think that it's actually landing. And so when it's landing, then what it tells is all of its systems, its avionics systems, its navigation systems, say, I'm landing, I need to steer, and I need to brake to a stop. And so it allows us to test all of those systems together and do a controlled stop and test our landing. And so that's probably as close to a real flight test as we can get without actually releasing it in flight and letting it fly. So that's an example of one of the tests. We do a lot of integrated systems tests, making sure that our vehicle works with the Mission Control Center, which is in another building. We have a team up there right now. Make sure they can communicate to the vehicle, they receive telemetry from the vehicle, can command the vehicle through the Armstrong Research Center antenna farm up here and through all their telemetry systems. And so it allows us to do integrated testing of the whole system together just like we would with our spacecraft. And so those are a couple of examples of some of the testing we've done out here.
Sounds like there's going to be a ton of data to go through after all of this is done, and just for several months out here with all these tests, that's going to give you a good indication of the flight readiness for the vehicle and get it prepped for orbital flight. So let's just go over, for those who may not know anything about the Dream Chaser, it's going to the International Space Station for a NASA CRS-2 contract. Let's go through the background of what we're prepping for.
So what we're prepping for is we are working on what's called the CRS-2 program, Commercial Resupply Services 2 program with NASA. We won a contract that we started a little over a year ago, and our job is to actually build this vehicle and deliver supplies back and forth to the International Space Station. We're going to use this Dream Chaser vehicle that's behind us, not this exact one. This is our atmospheric vehicle. But this vehicle with a cargo module attached to it, go up to the space station.
Yeah, and we have a model here.
There we go, right here.
Show everyone what the cargo module
and
looks
so
like.
this is our cargo version of the Dream Chaser. The version behind us is actually a crewed version, but the cargo version, the differences being we don't have windows in the front, and color's a little bit different for the thermal protection system. But then what's most different about it is on the back we have this cargo module, this white shape in the back with the solar rays coming off of it. And what that cargo module holds is it holds pressurized cargo, a lot of additional cargo to the space station. The solar rays provide additional power to the vehicle during free flight operations. And then these boxes around it are actually external payloads that NASA needs up on space station that they'll actually remove robotically. And so this is designed to take up to 5,500 kilograms of cargo up to the space station. Will stay docked at space station from 45 to 75 days. They will resupply the space station, pull all the cargo out, and also critical science payloads that they need to conduct science up there. Then they'll refill the vehicle with all of the cargo they want to bring home, plus critical payloads, science payloads they want to bring back. Then we'll undock from the space station, run berth from the space station, fly it back, deorbit burn. The cargo module actually separates after the deorbit burn, and that burns up in the atmosphere. And then the vehicle will come back and land at Kennedy Space Center at the shuttle landing facility, same runway we used to land the space shuttle on. So that's the cargo version. What you see today, though, behind us is actually the crewed version, and it's an atmospheric test vehicle. So it's not designed to go to space, but it's designed to do ground testing. Ironically, right behind us here, right behind you, Kimberly, is hangar 4833, which
historic hangar.
It's a historic hangar.
Yeah.
It used to be the space shuttle hangar that they used when the space shuttle program was going. And in the early days, the space shuttle program, before they started flying to space, they had a vehicle called Enterprise. And Enterprise was their atmospheric test vehicle, which is the same thing as what we have out here, where they only flew atmospheric flight test with it. And in those days, what they did is they put it on top of a 747, flew it up to altitude. They were actually piloted, released from the 747. They flew it right back and landed it right back on the lake bed behind here to test before they did the orbital flight. We're doing the same thing, but instead of using a 747, we'll be towing our vehicle with a helicopter, releasing from the helicopter, but basically doing the same profile that Enterprise did. And so it's really an honor that NASA put us into this hangar.
Yeah,
we're actually in the
huge
same
honor.
location as Enterprise, and we have actually pictures of Enterprise, 40 years ago,
Yep.
in the same place that we have our vehicle today.
Yep. And we do plan on posting that side-by-side picture up on social media so you guys can see what that looks like. But I think just even being here on the ground and walking in that hangar, you can just feel the history of what we're walking into here. And, so many people, the shuttle program and the Dream Chaser, it brings back sort of a nostalgia of having a winged vehicle landing on a runway, and that just touches the hearts of people in just so many ways. I've heard a lot of people say wings are back, and just that excitement
That's
that
right.
wings are back.
Yeah.
Can you talk a little bit about what that means to have, especially having flown on the shuttle?
Yeah,
in the shuttle
I can
program?
talk about that, but first I wanted to mention something to the viewers that are watching. Armstrong Research Center, Edwards Air Force Base, has a rich history of lifting body winged spacecraft. The original research done on lifting body spacecraft was done right here at this very site. The earliest lifting body that NASA tested back in the old days, they actually towed airborne using a muscle car in the 60s. And they had a series of lifting body vehicles. For those of you that are really old like me and remember the $6 Million Man in the beginning scene in that TV series, with the vehicle tumbling down the runway, that was a lifting body right here at Edwards. Out of that history is where the space shuttle program came, because they did all the research that led to the space shuttle program, and certainly our vehicle came right out of that history as well. So there's a lot of history right here, and it's great to be back here at Armstrong, which started the whole lifting body movement, if you will, way back when, to be back here and be able to participate and have them as part of our team. The reason wings are important to us, and the reason I'm excited about it, is, of course, the space shuttle was the first winged spacecraft, and came in and landed, and it had an incredible amount of capability, particularly with the space station, because not only could it haul a lot of, besides people, but a lot of cargo up to space station and places like that. It actually assembled space station using the shuttle. It could also bring payloads back to the Earth. And what's unique about a lifting body instead of a capsule is during entry, instead of pulling 4 or 5, sometimes up to 8 or 9 Gs on entry, so it's a pretty violent entry, the a lifting body like our vehicle or like Space Shuttle comes down very gently, about 1.5 Gs. So it's a very gentle entry. Why
So for somebody who may not know what a G is, why don't you describe to the audience what a G is?
Yeah, let me explain a G. So standing here right now as we are, we're at 1 G. Okay, so it's basically your body weight. If you go on a roller coaster and you let's say you do a loop on a roller coaster, and when you feel yourself being pushed into your seat, that's more than 1 G. So typically on a roller coaster, you might feel 2 Gs or something like that when you're going around. So and if you weigh, let's say, 150 pounds, when you're at 2 Gs, then you feel like you weigh 300 pounds.
Wow.
So if you come in on a capsule and you're pulling 5-6 Gs, you can do the math and figure out you weigh 900,000 pounds. It's very very heavy. So if you're a sensitive payload, a science payload that you've been developing in zero gravity, in weightlessness, coming in that high G level, you can destroy that science. Well, because we come in like an airplane, essentially, and we're only pulling 1.5 Gs, so it's a very, very gentle entry, what you would feel on a typical airliner, we can preserve that science much better. And so by coming in gently, we don't hurt the science, and then we come in, and more importantly, instead of landing in the ocean and just smacking down on the ground under parachutes, we land gently like an airliner on a runway. And that does two things. Number one, it's a gentle landing, so there's no force put on the science or the payloads. But then the other part of it that's very unique about our vehicle that even Space Shuttle couldn't do is we have no toxic propellants on board. We have nothing hazardous on board. If you watched when the shuttle would come back, typically people would come up in escape suits and protective suits. They had sniffers, and they would check all around the vehicle, make sure everything was safe, and it usually took them about an hour and a half to get us out of the vehicle because they had to make sure the vehicle is safe. Because our vehicle doesn't have any of that on board, all we have to do is as soon as it lands, we can walk right up to it, open the hatch, and pull the sensitive cargo out.
Almost immediate access to that science payloads, and I know scientists love the Dream Chaser for that gentle runway landing.
Exactly.
And obviously it's beautiful to watch a spacecraft land. Steve, I want to interject here for a second and just welcome anybody who might have just joined us. We are live at NASA's Armstrong Flight Research Center for the Dream Chaser spacecraft captive carry test. We're going to watch the Dream Chaser get lifted up by a Columbia helicopter. The images are going to be incredible. Right behind us, actually, Steve, it got really eerily quiet for a couple moments. So I think they're finishing the final preparations for this. The sun is coming up. It's absolutely gorgeous and beautiful out here. Steve, what do you think? What do you think they're doing back there right now?
Well, what they've been doing is they've been working with Mission Control Center, and they've been powering up all of the avionics. And you saw the ground crew is back there inside, helping them, getting everything powered up, getting everything ready to go. Looks like they're just now closing out the back end. They've pulled the ladder away. They're doing the final checks on the vehicle. They'll probably jump in and do some flight control checks on our vehicle and things like that. And then they're going to start shifting the people away. They're going to put the pilots in the helicopter here shortly, and then they'll get the engine started on the helicopter and get ready to lift. So they're in their final preparations now. I just got word that they're going to do a radio check with the helicopter crew here at 7 o'clock, which is in about 15 minutes from now. So they're on track, maybe a few minutes behind. They had to work a little antenna issue this morning. We actually had because we're transmitting through a set of antennas that are up the hill behind us here. They actually had a truck sitting next to the vehicle that was blocking the lower antenna.
Oh, okay.
So they had to move the truck out of the way, and so that's accounting for a little bit of a delay, but so far everything's going really well.
Going as planned. That's awesome. Yep. Well, I think we're going to take a couple questions from some people on Facebook who are watching us.
Okay.
Philippe asks, what will make the Dream Chaser design better than the shuttle?
What will make the Dream Chaser design better than the shuttle? What really makes it better is our ability to, well, there's several things, actually. The first thing is the cost. We're smaller than the space shuttle. We're a commercial operation. We specifically designed the vehicle. It's reusable like the shuttle, but we designed it such that we can turn it around very, very quickly between flights. That means the amount of time on the ground is a lot less. The vehicle is a lot simpler than the space shuttle, and it's designed to operate a lot less expensively than the space shuttle. So that's one of the advantages. The other advantage, there are several other advantages. One of the things we did when we designed this vehicle is we had a lot of people like me from the Space Shuttle program that understood the shuttle pretty well. And we looked at all of the lessons learned from Space Shuttle, both good and bad. We tried to eliminate the the big safety risks on shuttle, like one of the Columbia accident was caused because there was debris that came off the external tank that hit the heat shield of the vehicle, damaging that heat shield. So instead of doing that, we fly on top of the rocket, or we fly encapsulated so that we don't have that hazard. That's an example. Our thermal protection system is much more robust than the space shuttle, so it's designed to handle micrometeorite debris on orbit and things like that much better. And then operationally, we looked at it, and we also looked at everything that was really hard to turn around in the shuttle that was expensive. Things like hydraulic fluid. Maintaining hydraulic fluid on orbit, believe it or not, is really difficult to do. We eliminated hydraulic fluid. I mentioned the non-toxic chemicals,
yep.
and the shuttle had what's called hypergolic fuel on board, which basically means it has an oxidizer and a fuel, and all they have to do is contact each other and they immediately ignite, and you can't put the fire out. Well, that's really hazardous to work with on the ground and difficult. And by doing non-toxics that we're using, you don't have to worry about that. So the vehicle's safer to work with on the ground. It's easier to turn on the ground, and then, as I mentioned before, as soon as you land, you can go right up to the vehicle and pull payloads off. So the other thing that provides us, besides being safer for the ground crew and easier to go up and quicker to get payloads off, it also allows us to land anywhere in the world.
And that is incredible. I just want to stop on that point because I can't emphasize this enough. Part of the Dream Chaser program and what Sierra Nevada Corporation is so excited about with the Dream Chaser is it can land at a regular airport. I just want everyone to think about that for a moment. Anywhere a 737 can land, a 10,000-foot runway, the Dream Chaser can land. And in fact, for other missions, we are actually looking at different airports in the middle of America where the Dream Chaser can land. And I think that just is incredible to think about families driving and watching a spacecraft land on a runway, and just what imagination that can bring for kids and
Yes.
for America to be able to watch that. And I think that just excites everyone about it.
Yeah, and there are a number of airports, both in this country and around the world, that are very interested in having us come land there. And so we've been working with those airports. They have to become what's called a spaceport and get some certain certifications. We work with the FAA on that and other agencies to make that happen. But that's one of the things that we're looking at. And so that's what makes it exciting for us. You may have heard we just kind of signed an agreement with the United Nations, looking at
Yep.
putting together an international mission with multiple countries, particularly focusing on nations that normally don't have a presence in space.
And that's incredible. I mean, just to point out, the United Nations has had an office for space for nearly 50 years, but hasn't gone to space yet.
Right.
So it's
Right.
just such an honor for SNC and the Dream Chaser to have this program.
Yeah.
And the United Nations is so excited. And as you mentioned, all these countries who can't afford a space program to be a part of space. It's so exciting. And that's supposed to happen in what year?
We are putting together we're starting to work the next phase with United Nations right now. I would guess probably late 2021, somewhere around that time frame, but we'll see how it goes. I mean, we have to put together the coalition of nations and obviously get our vehicle flying on cargo missions first.
Yep.
And so we'll see how it goes, but it is an exciting development, and looking forward to doing that. So
Excellent. Well, we're so excited. We're going to have the Dream Chaser captive carry test going to happen right behind us. We're going to bring you all the live footage. We're going to take a couple other questions. I think what I'm getting in from a lot of people is the specs compared to the space shuttle. So
Okay.
someone's asking, how different is the Dream Chaser compared to the historic lifting body, actually the HL10, which was the early prototype for the Dream Chaser, right?
So the prototype for the Dream Chaser was actually called the HL20, and this is an interesting story because it
It's a
kind of
spy novel, actually.
It kind of reads like a spy novel, and so where it all started was this was in the early '80s, and there was an Australian P3 flying over a Soviet trawler, and the Soviet trawler was pulling something out of the water. And so they took some pictures. The P3 took some pictures, and they shipped it back through Australian authorities, but then eventually got to RCIA. And they looked at this thing, and they were pulling. It was clearly a spacecraft of some sort. It came out of the water. They took the pictures to CIA. The CIA didn't, looked at them and said, "Well, we're not sure what this is. I'm pretty sure we want one." And so they handed that to NASA Langley in Virginia. And so NASA Langley looked at it, and they looked at the shape. They put the shape in the wind tunnel. They did a bunch of computational fluid dynamics on it and things like that. And they concluded this is a really good lifting body shape. And when I say lifting body, do you know what I mean by that?
I do, but why don't you recap
Yeah,
for the
so
viewers what that means?
when I say lifting body, what a lifting body is, it's a vehicle where the majority of the lift is generated by the body itself instead of the wings. You can see we have wings that are angled up at a pretty sharp angle here. In our vehicle, 70% of our lift is actually produced by the body itself. So the airflow comes over the body, the underneath and the overhead, and so this piece of the vehicle generates most of the lift, and that's what a lifting body is. Interestingly enough, the Space Shuttle is not a lifting body. The Space Shuttle is actually a winged vehicle. However, the flying characteristics of the shuttle, in terms of its lift-over drag and aerodynamic characteristics, are almost identical to this. And so in terms of performance, it's very much the same. So, but anyway, back to the story.
Back to the spy novel.
Back to the spy novel. So they reverse engineered this, and they created this thing called the HL-20. And HL-20 was the same size, basically the same outer mold line or shape as our vehicle today. We've made very few modifications to it. And it was designed actually to transport 10 people back and forth to the International Space Station. At one time, NASA considered it as a rescue vehicle for the International Space Station. Eventually, the program was canceled, and the HL-20 ended up, they actually made a full-size mock-up of it, and it ended up kind of on a back burner in a hangar at Langley. About 10, 11 years ago, my boss, who was with a company that later became part of Sierra Nevada, went to the
Mark Sarangelo.
Mark
Mark has been
yeah.
a huge supporter of this program and really the leader in this, along with Aaron and Fadi Osman, who own Sierra Nevada Corporation.
Correct.
We definitely want to give a shout out to them because
Absolutely.
they've given so much to this program.
Yeah, we wouldn't be here without them.
Yes, exactly.
So, thank you. But anyway, so my boss, Mark Sarangelo, asked the NASA administrator, well, we'd like to license this technology and take it to the next level. And so we got actually the computational fluid dynamics, the wind tunnel test results, as well as the mock-up itself from NASA, and we licensed it. And from then, we developed that into what we have today, which is called the Dream Chaser. And so one of the most interesting things is about 4 or 5 years ago, I think it was, Mark was back over in Russia. And, since the time of HL-20 and now, the wall came down and we had much more access to Russia. And he actually got a chance to go talk to the original engineers. And by the way, the vehicle the Russians have flown was called the Bor-4. And it was actually a vehicle used to test thermal protection systems for the Soviets' version of the space shuttle, which was called the Buran, which actually flew one time without people on it, and then it was retired. But we actually have video or photos of the P-3 flying over this Bor-4, but he also got the video from the trawler of the P-3 flying over as it was coming out. And so to see both of those is incredible. And the engineers in Russia, those that we could find, are really excited that we're doing this, as well as the folks in Langley. And looking forward to us succeeding on this and taking their design to space, which is what they wanted.
You just think about decades of work and just the different entities who have gotten us here today for the Dream Chaser. I just want to go back to a couple of Facebook questions that we're getting. Susan wants to know, when is the actual first mission scheduled? We're expecting around 2020 for the Dream Chaser to take cargo to the International Space Station. Another question we're getting is how many people can go on board, and when will it be taking people to the International Space Station? So just want to be clear about that. This is a cargo mission. Right now, the Dream Chaser has the capability to have up to 7 people on board. It can handle crew. Right now, SNC is building a cargo variant with the cargo module, so that's what we expect to go up. Other questions we're getting is a size comparison to the shuttle. The Dream Chaser is actually about 30 feet, so I've heard it described as the sassy, greener, leaner little sister to the Space Shuttle. And the Space Shuttles were actually about 120 feet. Is that right? Mm-hmm. And what about weight size? We have someone asking about the weight size comparison.
The shuttle weighed about 10 times more than the Dream Chaser. Typically, just the orbiter vehicle itself is about 10 times more. So it's quite a bit bigger. The Space Shuttle was designed to carry people and cargo. We can carry some cargo with people. We're pretty much either cargo or people. So a much smaller vehicle, but also gives us the ability to fly in conventional rockets, where the Space Shuttle needed their own custom
so let's actually talk about the rockets. So the Dream Chaser will actually, let's take it off here.
Okay. Don't break it.
Maybe not. Okay,
There
there
you
we
go.
go. Okay, so the Dream Chaser will be on an Atlas V rocket for its first 2 missions.
Correct.
And let's describe the fairing, and the wings will actually be folded up. Is that right?
Yeah, so it's actually in a 5-meter fairing, which is a standard fairing that the Atlas rocket built by ULA is. But the way this will launch is these solar arrays will be folded up flat against the cargo module on each side. And the wings are actually deployable wings. So the wings will be folded all the way in, and which allows the entire shape to actually fit underneath that fairing. So we'll launch in that configuration. Early in first stage, once we get it out of the atmosphere, that fairing actually separates, and then we're exposed, but we're in the vacuum of space by then, so there's no air loads. Once we get to orbit, the rocket will put us into a circular orbit, and then we'll separate from the rocket, and right after that, then we'll deploy these wings and lock them in place, and then deploy the solar arrays, which will give us power to recharge the batteries of the vehicle. And then it'll end up in the configuration like this.
Cool. Well, we have one question from somebody out on Facebook who wants to know, will the spacecraft be going to Mars? So I guess we should talk about its capabilities and where it goes
Sure.
up in space.
So, unfortunately, the spacecraft will not be going to Mars. The Dream Chaser is really optimized and designed for low Earth orbit, orbiting around the Earth.
So let's give an idea of how many miles we're talking there with low Earth
Low
orbit.
Low Earth
We call it
orbit
LEO, right?
is Leo is probably, for us, is roughly up to about 1,000 kilometers, maybe 1,200 kilometers.
And
circular.
how long does it take to go that far in the Dream Chaser?
Oh, about 12 minutes, something like that.
That's insane.
So-
12 minutes.
Yeah.
Incredible.
Yeah, so it's but we don't intend to take it to the moon or Mars or interplanetary, mostly because what's unique about it, the wings give us the ability to land on the runway and do all the things that make low Earth orbit really practical. But those same wings, for example, going to the moon where there is no atmosphere, it doesn't make a lot of sense to carry
Sure.
the extra weight to the moon. And so we're really designed about low Earth orbit, and really our focus is commercialization of low Earth orbit.
Excellent. All right, Steve, I just want to recap for anyone who might have just been joining us. My name is Kimberly Schwann, Communications Manager for Sierra Nevada Corporation Space Systems. I'm joined by Steve Lindsay, who's heading up the Dream Chaser program, former astronaut, Vice President of Space Exploration Systems for SNC. We are here in the Mojave Desert, NASA's Armstrong Flight Research Center. Behind us, we have all the action of the Dream Chaser, which is undergoing a captive carry test today. The Dream Chaser will be held up by a Columbia helicopter. We're waiting for that to happen any moment now. We're going to bring you all the live coverage. Oh, and by the way, we're taking your questions, so be sure to leave those in the comments section. So, Steve, what do you think the crew, it looks like we don't see as many people out there right now, so what do you think's going on?
Well, I think the helo crew is in the helicopter getting it ready to fly. They're going to do a radio check with our Mission Control Center, which is in a building about a mile down the road here. In a few minutes, looks like the vehicle is clear, and basically you can't really see it from here, but there's actually a long line, a 200-foot line, attaching the helicopter to our lift frame on top of our vehicle right now. So they're all hooked up, ready to go. What you're going to see in a few minutes when we get the helicopter going, helicopter will get airborne. It'll go into a hover right on top of our vehicle. And I think I hear the auxiliary power units firing up right now. And then they will lift it up. And what we're going to do on this captive carry is we're going to do several laps right down the runway or right in front of the runway. And we're going to basically practice the flight profile, what we'll be doing in flight to get into what's called a drop box. We have to get to a certain drop box, which gives the vehicle a certain airspeed and altitude, which allows them to release the vehicle, go into free flight, pull up, land on the runway. And so they'll be practicing that today. So it's
Sounds like she's going to get a workout doing these laps, the Dream Chaser. I'm tired just listening to it.
yeah, and the helicopter's going to get a workout too.
Yes.
The helicopter crew, they have a tough job because their job is to fly the vehicle safely, get to the right altitude we need to, the airspeed we need to, have very precise altitude, airspeed, as well as parameters on the vehicle itself, like the yaw rate and roll rates and all of those. They have to get all of those. There's about 12 parameters. All have to come together right at once before we could be safe to release. We're obviously not going to release today.
Yeah, but that's in preparation. This is what today's test. There's going to be 2 captive carry tests
Correct.
for the Dream Chaser.
Correct.
And later this year, instead of just it flying around with the helicopter will actually drop the Dream Chaser. It will go in for a landing. So that is expected to happen later this year.
Correct.
Which is very exciting. And then
Yes.
really the orbital plan happens after that. So the testing is critical to get to that point. And everything's going well so far. The Dream Chaser's been out here since January, as we mentioned earlier. But today's a big day, and we're going to have these incredible images
So
right behind
let
us.
me mention what we're going to be getting on this test. So on board the vehicle, we have all of the orbital vehicle avionics. So the avionics on board today are identical to what we have in the orbital vehicle, as well as the flight software for the orbital vehicle. So getting this test complete when we do the free flight, we'll actually test our orbital vehicle flight software or orbital vehicle avionics, and that's why it's so critical to us. So it will test that. It will also test the aerodynamics of the vehicle. Now, we flew it once before. We know kind of how it flies, but we're going to test that again. We're going to get additional aerodynamic data, which helps us in our design of the flight control system and a few other things. And so we'll test this shape to make sure this shape flies as we expect it to fly.
And I guess we should be clear that one of the unique parts about the Dream Chaser is it actually doesn't need a pilot, which this still is mind-boggling to me, that computers completely will lift off the Dream Chaser, dock it, or berth it to the International Space Station. It comes back for a landing, and it doesn't even need a person with a joystick, so to speak, on a computer running it. It's completely autonomous.
Which is really hard for me since I'm a pilot. The question is, can the computer fly it as well as I can? No.
You don't think so?
No.
Well, okay, so I guess this is a good question, Steve.
But all the engineers say yes.
Right, of course,
So,
of course.
depends on who you talk to.
So, Steve, are there any plans for you to go on the Dream Chaser?
I don't know.
It's got to be hard for you to be sitting here looking at it.
Yeah, I know. If we do a crewed version, we'll crewed version will have pilots, and we'll have to flight test again with pilots on board. And but the vehicle the intent has always been for the vehicle to be able to fly automated as well.
Right.
And so we'll certify to an automated uncrewed vehicle. We actually needed to do that for space station missions because, for example, if a space station crew's been up on orbit for 6 months, when they come down because of the neurovestibular, the medical effects of coming back into gravity, they can't really fly, and they can't be expected to fly. So the vehicle has to be able to do automatic landing. But so I guess the best way to describe the vehicle is going to be an optionally piloted vehicle.
Yeah, it has the capability of
Correct.
having it piloted, but
Correct.
it's nice to have the option to not have to
Right.
worry
Right.
about it. And the completely autonomous is just, again, it's still mind-boggling.
Yeah.
So, Steve, we're hearing a little bit of noise back there. I'm hearing the crew brief might be over, and it sounds like they're getting ready to fire up the helicopter.
Yeah, it does. I think the sound you hear right now is it's called an auxiliary power unit that's on the helicopter. It's actually a little tiny jet engine on a helicopter that powers up all the avionics, allows them to turn the rotors, and so they're going through their pre-flight checks is what it sounds like right now. And so I would expect to see those blades start turning here real shortly. And you notice the vehicle's clear. Actually, looks like got somebody. Yeah, somebody up close right now, but they're getting very, very close.
So, Steve, when they get all this data, how long does it take to go through every information that they're going to get back from this test? Is it immediate, or does it take weeks, months? How long does it take, or do you know immediately how it did?
Everything on board the vehicle is being telemetered to the Mission Control Center, and it's being recorded, and they're looking at it all real time.
So for someone who may not know, why don't you give us what telemetered is and what kind of data that is? It's very specific.
So telemeters is just like your cell phone when information from the internet comes to your cell phone. Essentially, we're radiating information out of the vehicle through our antennas. It's being picked up by ground stations, and then it's going in the mission control room, and it goes into displays and controls they have and we have special displays and controls that our team has built for looking at the data in an intuitive fashion. So they have we have multiple stations within Mission Control Center. Like we have a mechanical systems station where all of the flight control systems and the landing gear and the brakes and all those mechanisms, they're getting all that data in their location. And we have a avionics group that's looking at the flight computers and the radar altimeters and the GPS INS units and things like that. And so all of that data is going in, and it gives them the health and status of the vehicle. In addition, they have the ability to command to the vehicle, send it commands to activate this, turn this on, turn this off. And so they're looking at all that real time. When we do the flight, they'll be reducing or looking at the data for probably several weeks after we fly this flight test, looking at everything, looking at the health of the vehicle. Did it fly exactly as expected? Did the systems perform exactly as we expected? You do flight test for a reason, and no matter how well you design on the ground, when you get into flight test, you always have surprises. I spend a good portion of my career as a test pilot, and I would say 90% of the time I do a flight test and it went as expected, and about 10% of the time stuff happened that nobody even thought of. And so
And that's exactly why you do testing, right?
And this is why we do testing. And there's risk with testing, and that's what makes it challenging. That's what makes it scary at times. But it's something that has to be done. You can keep the vehicle safe if you keep it in the hangar, but at some point you got to go out and fly it. And so that's what we're doing today. I'm sure the team is going to learn new things today because we have all new avionics on board. We've done everything we can on the ground. They're going to get airborne. There'll be surprises. We need to understand what those surprises are, deal with those surprises, figure out if we need to make changes. Then we'll go fly it again, test those changes in another captive carry. And once we're completely satisfied with that, that's when we'll do the flight test.
So, Steve, let's take another question. Justin is asking, will the Dream Chaser stay attached today? So the Dream Chaser will stay attached, but why don't you tell us how it's going to stay attached?
So if you probably can't see it, especially with the sun in the way, but there's a lift frame on top of that, on top of the vehicle, and there's 3 hard points that it attaches to on Dream Chaser, and it's actually attached through 3 hooks. And these hooks actually come from the logging industry.
Interesting.
So they're very heavy duty, highly reliable hooks, and they're synchronized to all 3 release at the same time. So the day we do the drop test, we have one of our SNC employees in the helicopter who will actually push the button, which will release all 3 of those hooks. The Dream Chaser will fall away and fly back to the runway. For today, we have that same person in the helicopter. I just talked to him and said, "Carl, make sure you don't push that button." But he already knew that. I was just kidding with him.
And Steve has a very dry sense of humor, and he has these one-liners, and you're kind of thinking, wait a second, are you joking or not?
So the system is hooked up today, but obviously not energized, so it will stay attached today. Additionally, we have an additional set of straps that are hooked directly between the vehicle and the long line of the helicopter, so that just in case we had a problem with a hook, it's not going to drop the vehicle. So there's no way the vehicle will release today. The one exception would be if the helicopter had an emergency itself, the helicopter can actually release from underneath the helicopter. There's an additional safety release point, because if the helicopter were to lose engines or something like that and they were an emergency, then they have to have an ability to separate the vehicle. But we obviously don't anticipate any of that happening today. So it's not going to release this time, and we've taken safeguards to make sure it doesn't release this time. One thing I will tell you, though, is after we're done with this captive carry today, we're going to set our vehicle back down and set the helicopter back down. We're going to take the lift frame off the helicopter. We're going to put sandbags on each of those 3 hooks.
Yeah, I was hearing about this yesterday. This is so interesting.
And then we're going to lift the lift frame by itself up with a helicopter, take it about 10 feet in the air, and then send the signal to release the sandbags, which will give us a good integrated test of our release system. We've already done that on the ground, so we know it works, but why we want to do it with the helicopter and a hover is we want to get the same electromagnetic interference effects, because when rotor blades are spinning, they generate static electricity, generate an electromagnetic field. We want to make sure that field is not going to interfere with our ability to release the hooks and get a good simultaneous release, which will be a good integrated test before we go into flight test.
So, Steve, we're out here in California. The Dream Chaser has sort of been living in its home away from home here at NASA's Armstrong Flight Research Center. The vehicle and the orbital vehicle, though, will actually be manufactured in Colorado, which is Sierra Nevada Corporation Space Systems is headquartered there. SNC's main headquarters is in Sparks, Nevada. Sierra Nevada, for those who may not know, is a defense contractor, an aerospace company, actually been to 7 planets and has hardware that's been on tons of missions in space. So the vehicle, and it's home away from home here in California, but the orbital version will be built shortly in Colorado. Is that right?
Actually, the orbital vehicle is being built right now. The primary structure is being built. We've partnered with Lockheed, and the same factory where they're building the F-35 right now, which is also being flight tested here at Edwards. They're actually building our primary structure there. So we have a team of SNC folks along with a team of Lockheed that's in Fort Worth building our primary structure right now. In addition, we're obviously hot and heavy into design, approaching critical design review on the orbital vehicle, already procuring a lot of the long leads and the parts and the avionics boxes and things like that for the orbital vehicle. So all that build is going on right now in parallel to what we're doing out here.
Excellent. So I just want to welcome anybody else who might have just joined us. We are live at NASA's Armstrong Flight Research Center, Behind us, the captive carry test for the Dream Chaser space vehicle. We are in a historic location. Right next to us is the hangar where the Enterprise shuttle was tested. It's been the same hangar that the Dream Chaser facility has been in over the last few months. We are eagerly awaiting. We can hear the helicopter actually getting fired up right now. So we know that we're getting close. We have a beautiful sunrise this morning. We're going to bring you all the live action. And be sure to leave us any questions in the comment section, and we're going to hope to be able to take some of those throughout the rest of this broadcast. So, Steve, do you see anything happening out there right now?
I'm watching. They're not talking to me. Nor should they. I think they're getting close. So I haven't heard anything. Haven't heard anything from Mission Control, but I think they're getting really close. So they have the crew. You have the crew chief. There's always a crew chief on the ground by the helicopter as they're getting ready to start engines, and they're just watching everything as they power up. But I think we're pretty darn close here.
And so one aspect of this I know is that for Mission Control and the team in there, that this is critical for what they'll be able to get, and this is a run through for them as well. So tell us what might be going on in Mission Control. We always have those iconic images of everyone sitting staring at their computers. So what is that team doing right now?
So in Mission Control, the everything we're doing out here is completely scripted. So we have they essentially have a series of checklists, and they're going through that series of checklists. We have a power up the vehicle checklist. Ground had a checklist they went through to get the vehicle ready to go. They're going through that checklist, and they go through each one of those checklists, and depending on what station has the responsibility, then they're sending the commands, verifying data, making sure the vehicle is in the state that we need it to be in to be able to go fly. And so once they get through all of those checklists, then eventually they reach a point where they'll clear them for engine start. And the helicopter will do engine start. They'll clear them for liftoff later and things like that. So they're following a very specific checklist. We also have what are called flight rules. And flight rules govern what you do and how you do it when something happens. And so, like, an example of a flight rule is for today we have a certain weather criteria for the flight rule, a certain amount of maximum wind and things like that. And the reason we do flight rules, it's really critical activity, because when you get in the heat of the moment and you're running a mission like this, it's really easy to say go, 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 go. And the flight rules are predetermined rules that keep you within the parameters of your flight test. So they don't allow you to change things on the fly and take additional risk when you shouldn't be taking additional risk. So we're going to, we'll fly this captive carry, we'll fly our flight test when we're ready, but not before. But the flight rules keep you real time so that in the calm of preparation, you're setting your boundaries and not in the heat of the battle. And so that's the whole intent. So they're following these flight rules. They're making sure they stay within the flight rules, powering things up. If certain things don't power up, they won't fly. And so that's the purpose.
So we have a question from Kong, which he asks, will the spacecraft have the ability to land at any airport? The Dream Chaser can land at an airport anywhere a 737 can basically land. And in fact, Huntsville, Alabama just entered a phase 2 to see if the Dream Chaser can land there. So wanted to answer that question that yes, it can land at a runway.
Absolutely. It's specifically designed to. All right, they're starting their engines. Looks like the rotors are turning. It's going to get really, really loud, so you may not be able to hear us.
So we expect it'll be about 5 minutes for it to power up. Is that right, for the helicopter?
Yeah, I think so. I'm not really sure. I've never flown one of these. So, but yeah, probably 5 minutes or so, and got to get everything warmed up, get all the avionics going, and test their systems, and then they'll be heading out. So.
And I know one thing, there's a NASA meteorologist who's usually on hand and looking at literally a minute-by-minute weather forecast of what we can expect out here. So it doesn't seem pretty windy. How do you think the weather conditions are looking today?
I think it's going to be really hot today. What
108 degrees,
other
actually.
than being really hot, and I think it's fine. The winds are calm. For the captive carry, our winds aren't as restrictive as for the free flight test. So I think it'll be fine. I think the biggest issue we'll have today is because it's so hot so early. It's a very, very hot day. That affects the helicopter performance. And so they may, when they go to the high altitude laps today, they may not get all the way up to our drop box conditions, but that's okay for this test, because what we really want to see is the speed and the location, and it's not really our primary objective. So when we do our flight test later on this year, it'll be a cooler day and they'll have plenty of performance. So I think if we see anything different today, they won't go as high. So.
Gotcha. And part of the weather, which is why this spot is so great for this kind of testing, because it's pretty predictable.
It's predictable weather. We don't get a lot of, not a lot of clouds here. Having the big lake bed and the runway kind of away from populated areas makes it a really safe place to flight test. That's why it's here. That's why it was originally created.
Okay, so for anyone just joining us, we're looking at the helicopter, the Columbia helicopter, which is going to be carrying the Dream Chaser spacecraft. The captive carry test is expected to get underway at any moment. We have Steve Lindsay here who's giving us a play-by-play of what he sees. And it's a beautiful sunrise, and we are just getting close to live action here for the captive carry test.
Yeah, so Kimberly, looks like they're starting. You can see there's a couple of their crew chiefs out there just checking everything out. Eventually, they'll do a walk around the vehicle. I don't know if they're intercom. It doesn't look like they're plugged in. So, and then they'll get well away from the vehicle. You can see one crew chief standing out in front, which will be kind of giving the helicopter crew guidance as they lift off.
I can't describe enough just how majestic it is. The spacecraft is so beautiful, and just to see it here with the sunrise out in the middle of the desert, mountains in the background.
Yeah, and you'll see when it lifts off, that helicopter carrying our vehicle underneath. That's not something you see every day. It's a rare, very rare event. We're the only, just about the only, or certainly the only commercial lifting body out there in the world right now.
I think we're getting close to those geek out moments when we see it lift off.
Okay, they're lifting off now. You see the front wheels off. There they are. You see? Okay, now what's going to happen is they're going to go to a location right on top, right over our vehicle, and then eventually lift it off. So you'll see that happen here shortly. So the pilots, they have, you see those blisters? They have kind of plexiglass bubbles, so they're able to look directly underneath and see what's going on. So that's how they do their precision. These guys, set power lines and ski towers and things like that, and do a lot of precision flying. And that's so the helicopter is specifically designed for what we're doing here. And so you'll see them. They're going to drift slowly over this way toward our vehicle and get right over top of it. He's kind of guiding the long line, and then he'll eventually lift off here. So he's just about getting in position. And that's about a 200-foot long line. You can see the cable stretching on the vehicle underneath, and he's about to lift it off. Now he's going to add some power. can see how steady the helicopter is. In a very precise manner. He's going to gently lift off here shortly. Okay, he's adding power. And there we go, liftoff. Not something you see every day.
No, it's incredible.
Now he's going to rotate his nose around, and then they're going to start heading over to the lake bed. And there he goes. So he's going to go out over the lake bed now, and there's a compass rose out here, and they're going to make once they get the vehicle oriented, they're going to make a couple of 90-degree turns to basically update our inertial navigation system and our attitude system, and then they're going to do a couple of low altitude passes, basically to burn off helicopter gas and get some high speed passes on our vehicle, basically to get some aerodynamic data for our flush air data system. That's the system that we get angle of attack and airspeed and things like that from. So we want to get some low altitude testing to that. Helicopter will burn off a little bit of gas, and then once they've done a couple of passes and burned off some gas, then that will enable them to go up to higher altitude, closer to drop altitude. And then they're just going to do racetracks and practice the run-in line, getting into the drop box with a team.
Sounds like a lot of exercise the Dream Chaser is going to have doing all these laps today. And I think just that image, just majestic is the word that comes to mind, and just having the sunrise and that beautiful spacecraft being lifted up and just seeing it in the air, it just gives you chills how beautiful the vehicle did. So your assessment of how things looked so far?
So far they look good. I need to see all the data, and I can't see it here, but
you need to see the telemetry.
I need to see the telemetry. But so far everything looks okay. Their op here lifting off looked great, and so we're gonna learn a whole bunch right now. So that's why we test.
So, Steve, I want to take a couple more questions from those watching us out on Facebook. Daniel wants to know, how long do you think the Dream Chaser will be in commission?
Well, the Dream Chaser, the vehicle itself is designed for each airframe is designed for 15 flight reuse as a minimum, and we'll get more data once you fly it to see what it really is.
And that's one of the greatest aspects about the Dream Chaser, is the fact that it can be used 15 times. Basically, it lands back, some refitting happens, but then it can go right back up into orbit.
Yeah, as far as the Dream Chaser program itself, we have designs on flying long past space station and basically being a permanent presence in low Earth orbit. So we're hopeful that the program lasts long past my career, at least. Maybe not long past your eyes. I don't know.
Well,
You're a lot younger than I am.
around the office, a lot of people like to say that the Dream Chaser is literally going to change the way the world goes to space. The Dream Chaser spacecraft is made by Sierra Nevada Corporation, and we actually have a question from Brooke on Facebook who says, tell us more about what SNC Space System does.
So SNC Space Systems is one of our business areas as part of SNC, the overall company. But the Space Systems group is located in Louisville, Colorado, so we're right near Boulder, actually between Denver and Boulder. And what our group does is, besides the Dream Chaser and what we've been talking about today, we also do satellite components. So we do things like precision gimbals, thermal louvers, precision, like we built the wheel mechanisms for a lot of the Mars rovers. As Kimberly mentioned earlier, we've been to every planet in the solar system that NASA's gone to. I think we've been to Mars something like 12 or 13 times. We built parts for all of the rovers that are currently on Mars now, and all of the systems and on future systems. And so we build a lot of precision components for satellites and things like that. We also have a small satellite group that builds small satellites. Recently we put up a constellation of 17 satellites called Orbcomm-2, and those are small satellites that actually track shipping around the world. And so we have a satellite group, and then components group, and then then of course the Dream Chaser program that I'm part of. Additionally, we are just starting another program at NASA called Next Step 2, where we're building a prototype habitat for their Deep Space Gateway. That's the next program NASA's working on, a Deep Space Gateway that will be in lunar orbit, that constellation NASA's rocket will be going to with Orion, and basically the plan is to stage interplanetary missions out of that Deep Space Gateway. So we're a part of that as well.
That's incredible. The idea that you could live in space, go deep exploration, that is incredible. Yeah. And part of that, I want to give a shout out to our office in Madison, Wisconsin, which is actually making fresh food on the International Space Station right now through the Veggie and APH program, and really advancing plant science. And if we want to live in space or go deep into space, as you were just talking about, we need to be able to eat fresh food. So that's an incredible program that SNC is a part of too.
Yeah, and to your point, Madison group, that one of our groups up there, they not only do the Veggie experiment that's on Space Station, do a lot of plant work. Recyclable. Some of the if you saw the Space Station astronauts eating lettuce in space, things like that, that was Orbitech, our group up there that did that. They also build rocket engines, and they're building rocket engines for our orbital vehicle, and they have a outstanding technology up there, a good group of folks, and so they are heavily invested in space as well, and a critical part of our organization.
All right, I think we're going to try to wrap it up here, so I'm going to take one last question from our Facebook land, and we have, let's see, Brian is asking, can Mission Control take control of the vehicle if the automated system fails? So what happens with that?
So Mission Control can take control of the vehicle. However, for this particular flight test, once we release, the time of flight from release to landing is about 60 seconds. So they can send commands, and in fact they're set up to send backup commands to mode the vehicle in certain ways. Like for example, today when we come back in and land, we're going to set the system automatically to deploy the gear when we get to about 200 feet. If for some reason that doesn't work, then Mission Control can manually command it. So the Mission Control can manually command everything. However, when you have a really short time of flight and not a lot of time to make decisions, generally speaking, the way we deal with that is, rather than having the ground sending a command, we have backup systems that protect us if the first command doesn't work.
Well, Steve, I know you probably have just a few things that you have to do today, so we should probably close up this segment, but it has been a pleasure to get your information and just have you kind of do a play-by-play as if this were a sporting event. And getting your information was incredible, and I know everyone watching is so grateful for you to take the time to give us your expertise, and we're so grateful for everyone who watched today. Thank you for tuning in right here from NASA's Armstrong Flight Research Center. We're so excited to bring you the Dream Chaser captive carry test. So on behalf of Sierra Nevada Corporation and the whole Dream Chaser team, we want to say thanks for tuning in, and don't forget to chase your dreams.
Thank you. Thanks for joining us.
Bye, everyone.